Right now, 4 astronauts are training to fly to the moon. They have a rocket, they have a spacecraft, they have a launch date. What they might not have is time.
Because scientists just discovered something about our sun that changes everything, and the timing couldn't be more alarming.
A research team has developed the first method in history that can predict when our sun is most likely to unleash its most catastrophic storms, not just regular solar flares, superflares. Events so powerful they make the worst storms we've ever recorded look like gentle breezes. And according to their model, we are sitting inside one of those peak windows right now, as in today, as in the same window that opens directly into the planned launch of NASA's Artemis II mission. The same mission that would send 4 real human beings beyond Earth's protective magnetic shield. This isn't speculation. It's published in the Journal of Geophysical Research, Space Physics, and it has real mission planners asking hard questions. But here's where it gets really interesting. Because this story isn't just about Artemis, it's about a threat that has already nearly destroyed civilization once and almost did it again just 2 years ago without most people ever hearing about it. Let's back up to September 3rd, 1859. An amateur British astronomer named Richard Carrington is at his telescope casually sketching sunspots when he notices something that shouldn't be possible. An intense white light erupts from the sun's surface. He watches for 5 minutes. It fades. He writes it down and moves on.
17 hours later, the world woke up to fire.
Telegraph lines across North America and Europe exploded with current. Operators were electrocuted by their own equipment. Telegraph paper burst into flames. In Colorado, gold miners stumbled out of their tents at 1 in the morning because the sky was so bright from the aurora they thought the sun had risen. In the northeastern United States, people read their evening newspapers by the light of the northern lights, visible as far south as Cuba and Hawaii. That was the Carrington Event, the largest geomagnetic storm in recorded history, and it struck technology that amounted to copper wire and paper. Today we have satellites, power grids, GPS, the internet, air traffic control, financial systems, pacemakers. Researchers at Lloyd's of London estimated that a Carrington-level event today would cause between $1 and $2.5 trillion in damage to the United States alone and could knock out power for months because the high-voltage transformers modern grids depend on take years to manufacture. That's the baseline risk, the thing scientists already knew. But there's something most people don't realize about solar storms. There's a category above what Carrington experienced. Astronomers have observed them on other sun-like stars. Events 10, 100, even 1,000 times more powerful than what hit Earth in 1859, we've called them superflares. And until now, we had almost no ability to predict when they might happen. That's what just changed. Dr. Victor Velasco Herrera and his team at the National Autonomous University of Mexico spent years analyzing 50 years of X-ray observations of the sun from NOAA's satellites. They weren't looking for individual flares, they were looking for patterns, hidden rhythms nobody had identified before. And they found 2, a cycle repeating every 1.7 years, a longer one repeating every 7 years. When these 2 cycles align, the probability of an extreme superflare spikes dramatically. Think of it like ocean tides, regular daily tides, monthly cycles tied to the moon. And occasionally, the alignment creates something called a king tide, far beyond the ordinary. What Velasco Herrera's team found is essentially the king tide calendar for our sun. Their model identified 2 danger windows for the current solar cycle, the first mid-2025 through mid-2026, right now, focused on the sun's southern hemisphere, the second early 2027 through mid-2027. And here's what makes this finding extraordinary. They submitted their research for publication before they saw the confirmation. Because after they submitted the paper, other scientists using the European Space Agency's Solar Orbiter spacecraft released data describing a series of massive superflares that erupted on the far side of the sun in May 2024, flares that included an X-16 class event, one of the most powerful ever recorded, erupting from exactly the region and during exactly the window the model predicted, data the team had never seen, a prediction validated by events that had already happened. The model didn't just work, it passed a blind test with flying colors. And this is where it gets personal, because NASA's Artemis II mission is scheduled to launch with 4 astronauts, Reed Wiseman, Victor Glover, Christina Koch, and Canadian astronaut Jeremy Hansen on a 10-day journey around the moon. For most of that journey, they will be outside Earth's magnetic field. That field is the invisible shield that deflects charged particles from solar storms. On Earth's surface on the International Space Station, you have that protection. Going to the moon, you don't. The last time humans traveled beyond the magnetosphere was Apollo 17. In December 9, the Apollo astronauts were lucky. Multiple times during the program, significant solar events narrowly missed their mission windows. In August 1972, between Apollo 16 and Apollo 17, one of the largest solar storms of the 20th century erupted. If astronauts had been in deep space during that event, the radiation exposure could have been fatal. That near miss wasn't planned, it was luck. Pure luck. Velasco Herrera's recommendation is direct. Delay Artemis II until the second half of 2026, when the current superflare window is predicted to close. The rocket was already rolled back to the Vehicle Assembly Building on February 25th for repairs. The launch is on hold until at least April. The delays that frustrated so many might, if this model is correct, be buying exactly the margin of time needed. What we're witnessing is something genuinely new in the history of human spaceflight. For the first time, scientists can read the sun's rhythms far enough in advance to actually plan around them, not reacting to storms as they arrive, predicting the seasons. The real question isn't whether to delay Artemis. It's whether this forecasting capability can be made reliable enough to protect every future deep space mission, every crew bound for Mars, every human being who leaves the protection of Earth's magnetic embrace. The window won't stay open forever. But right now, the sun is telling us something clear, and for the first time in history, we have scientists who are listening. Here's what I want to know. If you were one of those 4 astronauts and you knew about this research, would you push to launch anyway or wait? And do you think NASA is taking this model seriously enough? Drop your answer in the comments. There's a star 163,000 light years away that's also telling us something right now about how stars die and whether our sun might one day do the same. That story is coming next.